All right, so here we're looking at a couple different quadratic equations, and up until this point, a lot of what we've done has been factoring. You might notice that a lot of times when we factor it, it means we can think of the numbers that multiply to make this number on the end and add to make this number on the middle. So for example, for the red graph, numbers that multiply to make -3 and add to make +4. Those numbers don't work, they don't exist. And you can also see that if you look at the graph, you might notice that it doesn't go through nice numbers on the x-axis. And so when something is factorable, that means that it's going to go through these nice numbers on the x-axis that are either whole numbers or nice fractions. And if it doesn't go through those numbers, that means the thing's not factorable. So what we're going to do in this video is just talk about a different technique that is completing the square. So completing the square, it looks kind of like factoring. And what I'm going to do is I'm going to warm up, before I even take the red example, I'm going to remind you just a couple things. Like when we have a square, like let's say we had x plus 5 squared. What that means is, squared means times by itself, so I go x plus 5 times x plus 5. I can draw my little box. X plus 5, x plus 5, give me x squared, 5x, 5x, and then 25. So we end up with x squared plus 10x plus 25. So what I want you to notice is that when we squared it out, the original number of 5 turned into a 10, and it turned into a 25. The way it turned into 10 was we did 5 times 2. And the way it turned into 25 is we did 5 times 5. So we could say this is 5 plus 5, and this is 5 times 5. So what we're going to do when we're completing the square is we're going to work backwards. We're going to start with something that is in standard form like this. We're going to work it backwards to be in something that is a completed square like that. And so we're going to be splitting the 10 in half, taking the square root of the 25. That's the idea there. Okay? So let's look at our example. We have our red one, x squared plus 4x minus 3. I can split the 4 in half and make that into 2. If I do half of 4, I get, okay, so half of 4 is 2, 2 squared. Now you might notice though that if I do 2 times 2, I get 4. But unfortunately, the original problem doesn't have a 4 right here. It has a -3. So what I do is I go minus 7. Where does the -7 come from? Because the 4 from 2 squared needs to end up at the -3 that's in the original problem. So I need to think 4 minus 7 is -3. That -7 goes right there. Okay? So I'll prove to you that this completed square version is the same as the red graph. If I type in x plus 2 squared minus 7, you can see it lines up exactly on the red graph. Okay? So that's just an example of completing the square. Now, if we wanted to take that one step further and take our completed square and figure out where it hits the x-axis, we're going to set it equal to 0. And then we're solving by just doing the opposite to both sides of the equation. So the opposite of -7 is +7. The opposite of squared is square root. So we have x plus 2 equals plus or minus the square root of 7. There's two answers, a positive square root of 7 and a negative square root of 7. Square root of 7, if you grab a calculator, is 2.6-ish. So we have x plus 2 is about 2.6. And then how do we get rid of a plus 2? We minus 2. But there's two different answers, like you can see on the graph, and that's because we had the positive square root of 7 and the negative square root of 7. So we end up with our two answers of x is about 0.6 or about negative 4.6. So look at those two numbers right there. You can see that those line up exactly there. And I want to point out something. At the beginning of this video, I said that we wouldn't be able to factor it because we couldn't think of the numbers that multiplied to make negative 3 and added to make 4. Watch what happens if I go 0.6 multiplied by negative 4.6. Gets close to 3. The reason it's not exactly 3 is because I rounded it off. If I put a couple more decimal points in there, you'll see I'll get even closer and closer to 3. And if you add those two numbers up, you get 4. Okay? So that was an example of completing the square where the a value is 1. Now I'm going to do a harder example where the a value is not equal to 1. Let's look at this puppy here. So first, I have 3 in front, so I'm going to divide by 3. I'm not even going to do anything with the 44. So all I did was I divided 3x squared by 3, and I divided 24 by 3. Okay? Next thing I'm going to do is just ignore everything that's outside of the parentheses, and I'm going to pretend I was just completing the square on this. So that's half of 8 is 4. 4 squared is 16. So I just focused on the inside. Then I bring the 3 and the plus 44 down like that. Then I distribute the 3 to the two terms on the inside of the parentheses. I don't bring the 3 inside x minus 4's parentheses, just put it in front. 3 times 16 is 48. I still just have the plus 44 right there. Last step, combining the 48 and the 44 is negative 4. Just to prove to you that I got the correct answer there, we can go 3x minus 4 squared minus 4, and you can see that it lines up exactly on top of the other parabola. From here, the steps to figure out where this equals 0 are almost exactly like the other problem. First, we just add 4 to both sides, because that's the opposite of minus 4. 3x minus 4 squared equals 4. Then, divide both sides by 3. So I have x minus 4 squared equals 4/3. Then I take the square root of 4/3. Remember, I get two answers. I get a positive and a negative answer. So x minus 4 equals positive or negative. I got 1.15-ish. Last step is to add 4 to that. So the positive 1 plus 4 is 5.15, and the negative plus 4 is, what is that, 2.85-ish. And you can see that those two numbers land right there and right there. All right, so thanks for watching. Let me know if you have any questions. Happy to help.